So hello everyone, welcome back to another video from PyNet Labs. So in this video, we are actually going to discuss about CCNP certification. Now, for all of you guys who are actually preparing for your CCNP certification, you guys might already be aware like ENCOR is one of the most fundamental parts when it comes to CCNP certification. So in this video, we are actually going to go through some of the 5 topics that are like highly recommended for your ENCOR examination. All right. So fine, let's start. So the first topic that we might focus here is generally the EIGRP. So first of all, we are going to discuss about EIGRP. So as you guys might know, like EIGRP, you guys might have studied about EIGRP from your CCNP, and I'm pretty sure that you guys might be pretty much confident with the EIGRP fundamentals or the EIGRP concepts here. But in ENCOR, we delve a little bit deeper into the EIGRP. So in order to get confident or in order to get the EIGRP topic clear, you have to be confident about the basics things here. So you should be totally clear about the EIGRP fundamentals, like what EIGRP is, how you can configure EIGRP, and various terminologies that comes under EIGRP, like how EIGRP works, the type of database that EIGRP routers do actually create, and how an EIGRP router might actually communicate with some another EIGRP router. So here I have created some pointers that you might attend or like you might see when we are facing or when we are preparing for our ENCOR certification. So you should be aware of the basic configuration. You should be aware of the EIGRP terminologies. You should know like how to assess and understand the various database in EIGRP. And there is a term like that is known as wide matrix. Now, wide matrix was actually developed in order to support higher bandwidth. So the classic EIGRP configuration has a limitation that it cannot support higher bandwidth, like 1 TB or something more than 10 Gbps links, or let's say more than 10 Gbps bandwidth is not supported by EIGRP classic configuration. So as a fail-safe or as kind of like an upgrade, we came up with something that is known as wide metric. And at last we saw you need to be sure like how the metrics are calculated. Now, if you move on to the few second slides, so here are some of the terminologies that you should be totally aware of. Like you should be aware of the successor route, the successor, the feasible distance, the reported distance, the feasibility condition, and the feasibility successor. So these are some of the topologies that might actually helps you in understanding how EIGRP works. And in case if you are part of a network where in by chance, suppose your EIGRP configuration fails, or you are having some trouble with your EIGRP, then you should be aware of these terminologies in order to understand like uh, how or what is causing the issue. Moving on further, then we have you should be having a good knowledge about the EIGRP topology. So you should be able to understand the database that the EIGRP create. And besides that, you should be able to understand like how you can interpret the various information that is generally processed and created by EIGRP. So as you can see on the screen, I have a output of the topology table, and here you can see like it is showing you the information about the various interfaces or say various networks, and here we can clearly see the FD and the RD here. So here you can see like this is the FD. Okay, so FD stands for the feasibility distance, and feasible distance, the successor route, the feasible successor route, okay, and all the metrics here. So you should be able to understand like in an EIGRP network where you have like redundant network or redundant path to a destination. So how you can determine like which path is being preferred by the EIGRP. So you can only understand those all metrics when you try to understand the metric table here or the topology table here. Okay. Then we have the metric calculation. So as you guys might be aware of, like unlike other routing protocols, EIGRP is a bit complex when it comes to the metric calculation. So unlike other routing protocols where they might rely on 1 or 2 metrics in order to determine the best route, EIGRP here kind of like uses kind of like a composite metric, which is actually made up of 5 values. That is like bandwidth, load, delay, reliability, that's all. So combining all these values, we generally calculate the metric or the distance, like the best distance. So in here, the first formula that we have is something for the classic EIGRP configuration. Now, for those who have like studied EIGRP in CCNA, you guys might have recommended, or like you guys might have remembered this very formula. So this is the formula that we generally use when we have to calculate the metric from source to the destination. Okay, so we may not have to actually do this calculation here. It happens automatically, but in order to understand and assess the network scenario, you should be aware of this formula. So this is the classic metric formula that we generally have seen. And the bottom one formula is generally used for wide metric. Now, if you guys might remember, I just discussed about wide metrics. So wide metrics was actually incorporated into the EIGRP so that the classic EIGRP can actually compensate or manage higher bandwidth, like bandwidth higher than 10 Gbps. So if you are connected to a network link which is like supporting or providing more than 10 Gbps, so your classic EIGRP configuration may not be sufficient enough to handle those things or to actually assess that band. So for that, we uses the wide metric. Now the formula that you're seeing here, wide metric, is very much similar to the classic EIGRP metric formula, but here are few changes. Here, the delay has been taken out by latency. So instead of delay, we have now latency. And we also have an additional metric that is known as the extended. So in future, like suppose if new metric is developed or new metric is calculated, so that metric will be included in place of this extended. Okay, now moving on further. So we have the OSPF. So once again, OSPF is also one of the basic routing protocols that we have covered in our CCNA. But here in the ENCOR, we build a little bit more from our basic concept. So once again, when we are starting with the OSPF, you should be totally aware of the configuration, like how you can configure OSPF on a bunch of routers. Like you should be aware of the area concepts of areas, like what are the different types of areas that we have in OSPF. What are the different types of router types we have in OSPF? You should be aware of the DR and BDR concepts. Okay, you should be aware like how to read the LSA packets, how you can better optimize your OSPF network. So here are some of the neighbor states. So as you might know, like just like EIGRP, OSPF also establish adjacency with the neighboring router. So in order to create perfect adjacency, each OSPF router, they go through these stages. So they go through these 8 stages. Those are known as neighbor states. They all start with down, they move on to attempt, and they keep on going all the way to full. So when 2 or more router has gone through all these states, they consider each other as to be neighbors or adjacent, and only after the routers are adjacent, they actually share the information, like the network information, with each other. So this is something that might actually helps you in understanding how OSPF routers do actually communicate. And in case if due to some reason your OSPF communication is not working, you are not receiving OSPF information from your peering router, so you can actually interpret these stages. So you can actually go on further and interpret your OSPF configuration, and from here you can determine like at which stage or at which state your router is actually stuck, and from that you can basically troubleshoot it. Now coming up, here are a few examples. So we all know like this is the standard way in which we used to configure OSPF, but there also exists an alternative way where rather than using the network statement, you are actually directly adding the interface into the OSPF. Okay, so these are the 2 ways in which you can configure OSPF. And then when it comes to optimize, so you can to fasten up your OSPF process, you have to optimize your OSPF configuration. So here you can enable the passive interface. So when you configure a passive interface, the OSPF is not participating, or we can say that particular interface is not included in the OSPF process. So suppose if you connected to a network where you don't want to share your OSPF configuration, then you can configure that very interface as the passive interface. Okay, so it will save you a lot of time, and it will also save your router's precious configuration, like precious resources. So your router will not be wasting its time using or sending or accessing information from any of the interface through which it is not supposed to communicate. Now, once we are done with the optimization, we come towards the LSA configuration. So LSA, as you know, link state advertisement, the things or the kind of like information that each router exchange with each other in order to stay updated about the network changes. So there are a couple of LSAs that we are totally aware of, like say type 1, 2, 3, 4, 5, 7. So these are all your IPv4 LSAs. So whenever you connect multiple routers together, so the routers, they do exchange. Now, in order to understand like what kind of LSs are, how the routers are actually communicating within the area, within the other areas like area 0, area 1, area 2, and even to outside area. Suppose I might be connected to another domain, a domain using another OSPF PID, or say a domain using any other routing protocol. So in that sense, the information that is coming from the external network all the way to my internal network are basically categorized on the basis of this LSA. So in order to assess your network, in order to troubleshoot your network, this is something that you should be aware of. So in ENCOR, we strongly recommend that you be aware of the LSA types here. And besides this, we also have the OSPF version 3 configuration. So as you all know, OSPF version 3 is basically about IPv6. So here we also look into how we can configure the OSPF version 3. And also we interpret the metrics that is associated with the OSPF version 3 and the LSA that is associated with the OSPF version 3. Moving on ahead, the next topic, the fourth topic in our 5 ENCOR topics is QoS, that stands for quality of service. So quality of service basically prioritize the essential data that you want to send. So many a times when we are connected to a computer network, so there are like different types of net data or different type of information that is generally generated. So out of all the information that is generally generated on a computer network, there are some data that requires high priority. Suppose I'm communicating, you might be communicating with someone using a VoIP, you might be doing a video stream. So in order to ensure that you're having a very good experience with the communication, it is recommended that we use quality of service. So quality of service basically prioritize your voice or real-time data like voice, video, or anything like that, or your real-time data over the normal or general computed data. So how does this thing work? How does the routers recommend that a certain packet has to be prioritized compared to the others? So there are a few concepts that you need to understand in order to implement the QoS. Okay, so when it comes to quality of service, there are some models here. So let's say the best effort, the usual one, this is the default when you don't use or when you're not prioritizing any network packets or say any network information. So every packet or every data unit that a router or switch might be forwarding uses the best effort QoS model. Then it comes to the integrated services. So here the application, they basically adds some priority code to the packet or say some priority information to the network packet, and using that priority information, the data packets is forwarded. Okay. Then we have the differentiated services. So here the network basically identify. So the network here basically identify like which out of all the traffic that it is actually receiving, which traffic is the priority one, and based upon that priority, it forwards that particular packet compared to the others. And here are some methods that we use for classification. So there are some methods in which the routers or the devices participating in the network, they classify, they identify like these packets needs to be handled at a priority compared to the other. And this prioritization, it happens in every layers that we have. Okay, so it happens in layer 1, it happens in layer 2, in which in layer 2 we uses the .1 queue header. So the priority is added to the .1 queue header. In 2.5, we uses the MPLS, and in layer 3, we uses the DSCP and the IPP in order to prioritize our packets. Moving on further with the QoS, we also have some specific tools, or let's say some specific methodology that used to mark the traffic. So in the previous slide, we just look into how the devices tells like, or how the devices classify the packet, whether these packets or these information are priority based. And in this slide, we actually look how we can prioritize, or how like which methods can be used at a different layer in order to prioritize the packet. So when it comes to layer 2, so in layer 2, once again, like I said, in .1 queue header, we do mention the priority. In layer 2.5, that is for the MPLS, we have the EXP bits to highlight the priority. And in layer 3, we have the DSCP and the IPP once again to prioritize the packet here. Okay, so that's all about in the QoS. And now here we have some frame and packet format that basically defines how and where you put your priority. So as you can see here, we have the PCP bits, like something around like 3 bits. So these 3 bits are generally used to prioritize your Ethernet frame over other types of frames. So you might be communicating with someone in your LAN, and suppose you want to prioritize your packet, or suppose you might be using a VoIP device or something like that. So when you are using, so this PCP bits are generally used to prioritize your data packets. Like this, like frame, also we have the IP header. So in IP header, we have like TOS, and in this TOS, we have somewhat around like 8 bits around. And these 8 bits are generally used to prioritize your data packets. So that is how the QoS actually works. So when it comes to ENCOR, you should have a good knowledge about the quality of settings, how the QoS is marked or classified, what are the different models that we use in order to prioritize the general packet. And here we also have, you should be aware of the frames and the IP header in which the priority information is tagged. Okay. Now moving on to our last topic, it's all about security. So it basically deals like how you can secure up your enterprise network. So suppose you might be working on a router, you might be working on a switch. So we have already know like there are passwords that you can implement on your router to secure. But when it comes to an enterprise network, maybe passwords may not be sufficient for your every use cases. You might have to stick to ACL, you might have to stick to some AAA framework by using Radius and TACACS. So these are some of the things that we generally discuss in our security section. So starting with here, we come with the ACL. So we all know we have already worked with the ACL. Now, if you guys know, ACLs are of 2 types, numbered and named. Okay, and standard and extended. So standard are the basic one. So they by default blocks every kind of communication when implemented. When it comes to extended gives a little bit flexibility, but it also increases the complexity. So with the extended, you can define like which source is allowed to, or which source is restricted to communicate with which destination. Along with that, you can also prevent any of the particular service. Like suppose you don't want to communicate over telnet. So you can mention that in the extended. Now for your preference, you can use a number to define or identify your ACL, or you can actually use a name. Okay. Now, coming on towards the AAA model. So all you know, AAA stands for authentication, authorization, and accounting. So it's a kind of like a security framework that defines like when which device can access, what commands it can run, for how long it can run, things like that. Now, many times in a corporate environment, when you are taking a remote access, you might be facing the AAA framework. So when it comes to implementing AAA framework, we can do it by the Radius, and we can also do it by the TACAC. So these are like 2 options through which you can implement the AAA configuration or the AAA model into your lab or into your enterprise network. And lastly, these are the commands that you can actually run on your router in order to enable the AAA services. So you should be having a specific dedicated device like a server or something that might be running either the TACACS or the Radius service, so that your router can basically communicate with that. So every time you configure the AAA services, instead of your router locally authorizing the devices or the remote access, the AAA server here is kind of like acting as the authenticating server, which instead of router does the authentication and the access. Okay, so in this video, that's all we are going to cover. So please let us know if there are any specific topic that you would like to cover, and we will definitely make a video on this. So do let me know in the comments, what are your suggestions, what are your requests. So that's it for today, guys. See you in the next video. Thank you so much.